Hello viewers, welcome back. Today we'll discuss about functions. As we know that OB1 is the interface between our user program and the CPU operating system. Also, we can write down all of our logic in OB1. But if our program is large, like 100 motors and other control device input output, then our program will be very large and it is difficult to managing this program or difficult to trace out the program. So we can divide this program in other function called subroutine code block. This subroutine code block called function or function block. To create a function, we have to go add a new block, click the function and give a function name. So I am giving a name as a motor function. Language is ladder. Click OK. Create a new function. Here we can see here it's a function 1 fc1. We can write down all the function here. Suppose if our motor function for a dual start motor is like this, that first from the network 4 to network 12 11, then it is a big, actually this is a 40% of a dual start motor logic, because there is no interlock, permanent interlock with the other motor or the sequential start stop, local start stop. So it is a 30% and also there is no program for HMI. So if we create, still it is a long program for a dual start motor. If we create this program for 100 motors, then it will be large. So how can we optimize this function? How can we optimize the program? We can optimize the program by using function. To create, by creating a function logic. Here I have created a simple logic in function, like here input I 0.0, then I 0.1, I 0.2, and here is the command Q 0.0. We'll write down this program and then convert this program into a function, call function. Okay. CMD command. Now we'll download this program into the CPU. Going online, it is now gray mark, and I have before that forced this signal. So I have to call this function into OB1, function OB1, then write again, go here, see, now it is holding by force table, we can operate by now giving a stop command by pressing the stop button, because stop button is a NC signal, so always signal will be 1, so we have to force to 0 to stop. Now I am normalize the stop button again by releasing, and it will be 1. Okay, now I will create this function as a call block function. I will not create the whole program like this because it will need time to create this. I will just create a simple one network program. Okay, to do this I will call another function like motor call function fc, and also the language is ladder. Now if we create this function as a call block function, then we have to give a input output. So we can define the input output of this function, call block function parameter. Here is, we can click the drop down button here, down button, it will open this input output parameter. Here, from here you can see that this function, this instruction, dual instruction has 3 input. One is start, another is stop, and other is ready, and one is output. So we will write these three input here, and another is out. So we will make a logic with this input. So same way I will create this logic start. This is not physical signal, this is a input parameter signal of this function, call block function. You should not use the physical address like I0.0 peripheral input output in a call block function. You should not use, it will not work. Stop, then ready, and command by the CMD out, CMD command, now by command. Okay, see here command is the orange mark. Why it is orange mark? We'll check later. First download it again. So it is a function of a roll start motor. We will use this function as a call block function. To do that, we can call this function in a function or OB1. So I am deleting this one network. We will call this call block function into function. So it is look like this. We can reuse it again and again. If we have 100 motors, we can call again and again, and just we need to give the input and output. In function we have to assign all the formal parameter like input and output with a actual parameter, actual tag address. That actual parameter could be data block tag, local tag, or flag memory, or can be peripheral input output. So we have used that start signal as a I 0.0, stop as a I 0.1, and I 0.2 as a ready, and Q 0.0 as a output we have used. So we will only use for now only one block, but you can use for other block again and again, no issue. You can call as much as you want. Now download it again. If you call this function in a function, then you have to call those function like motor function in a OB1. I have called this motor function in OB1, and in this motor function I have called the call block motor function. So now we will simulate. Now ready and stop is okay. If we give a command here, command output should be there. Now I am giving a start command by pressing the start. Now output is generate. Now I am releasing. See what will happen. Now see, it is not holding. You can check what happened in a block. Just write down or right click on the motor block and go open and monitor. If you click on open, it will just open the logic, it will not monitor, go online. If you click open and monitor, it will directly go monitor mode. So now if I click start with this physical input, we can see the status of this input or in status of this logic. So I am giving start command. See, it is generating output command, and that command we have assigned a actual parameter q0.0. q0.0 is now true, but for holding, if we release the start command, then it will not hold because it is not green, it is not holding. To hold, this should be 1, and this is not 1. Why it is not 1? Because in a function we cannot use formal parameter out parameter as a input. So this formal output parameter command we cannot use as a input parameter. If you want to use the formal output parameter as a input parameter, you have to define this parameter as a in-out parameter. That command will be output. Also you can use this command as a input. So now download again. Specified call environment is invalid due to program change in motor block function made at later time. Reset the call environment. Okay, it is already reset by accepting. Now see, it is true and command is now inside, not outside. If you define a function in input output, then it will came in input side. Now I am releasing the start button by, so see that it is now holding. If I click the stop button, it will go 0. So command withdrawn. Now I am releasing the stop, then it will come to true. And if we give a command again, output is generated. Now I am releasing the command, it is hold. So we can write down all the logic like here, all the logic like this in this function. And when we call this call block function in a fc, another fc or another function, and then it will work. We don't need to write down all the logic again and again. Just we need to call and give a input and output parameter, then it will work. And one thing you have to keep in mind, that function has no memory that the data will store.